So thank you for joining to this Greenplum chat on what I think is going to be a great discussion on GPORCA, the Greenplum query optimizer, and also available for other engines to do query optimization. And we have a set of, actually we have panelists that are very interested in sharing their knowledge with you. So can you guys go ahead and introduce yourself? Start with Ivan.
Hey guys, Ivan Novick from Pivotal's Greenplum team, and I'm joined in the room here by Omer and Jesse, who are hidden behind the camera, who also are coders working on GPORCA.
Cool. I'm Venki, Venkatesh Raghavan. I'm the product manager for query processing. I used to be the developer for GPORCA, so I'm super excited to chat with you about GPORCA and its future.
Great. Jack, please go ahead.
Oh, hey, I'm Jacques Heistock. I lead the field for data here at Pivotal, and I'm happy to participate in this conversation. Super interesting.
And I think we're missing only one. Sin, please. Go for it.
Hey everyone, my name is Shin. I have been working on the GPORCA for the last year. This is very interesting query optimizer I observed. I'm so happy here to share what I learned. Thanks.
So as we all know, query optimization is an integral part of any database, relational database engine. And the Greenplum query optimization is open source and is modular actually. So it could be working with any other engine. So let's start basically with the definition of what is GPORCA. Can any one of you can take that specific definition and elaborate?
So, GPORCA, about in 2010, when Greenplum was coming out with 4.0, we saw that we need to have a query optimizer that is inherently aware of big data. So we have a lot of data and needed a killer shark to go at it and figure out the best plan to execute it, and also be disruptive able to handle disruption from the market, so new features can be added without rewriting the query optimizer. And at that point, the legacy planner, which is the Postgres-based optimizer, had not been rewritten for the past 20 years. So to add anything new there was very difficult, very challenging, and very buggy. So that's when we decided to rewrite the query optimizer to make sure that we can innovate for the future.
How long ago was this again?
So we started GPORCA around end of 2010, I think the first line of code was like December 2010.
And it's obviously currently an open source project, but did it start as an open source project?
So GPORCA was released in 4.3.5. So until only when GPDB went open source, after a couple of months, we open sourced GPORCA. And the reason also we wanted to open source GPORCA is that we saw in the Postgres community that people were really hungry for a modular next generation query optimizer, a volcano-based query optimizer, which is what GPORCA is also about. So we saw that the market is ready to absorb this. So we said that's the good time to open source Orca.
When you guys say modular, are there any other products that are using it?
So currently we have Hawk, which also uses the same query optimizer. So there has been initiatives from a couple of our team members and others who want to take Orca to run on traditional Postgres. We haven't heard how far they have gone through it. I know that some university grad students also are trying to do that, but I don't have an update on where they have landed.
Got it. Ivan, do you want to add anything to that?
Not yet. I'm holding up my questions and points. Let's keep going.
Right. So I assume the motivation of changing query optimization engines was related to the ability to run on big data kind of queries Was that the original intent of working on a new optimizer for Greenplum?
So we have had 30 plus years of research in query optimization. Every year in many research conferences as well as industrial conferences, we have seen new innovations that are being done by SAP, by Microsoft, by Amazon, many different competitors where we have come up with new optimization techniques. So those techniques have not been absorbed in a rule-based or a heuristic-based query optimizer like Postgres. So we thought that having all of those 30 plus years of research, which has been done by both academia as well as industry, we need to get started. But we want to start it in a way that is modular, meaning some new innovation comes in, new kind of architecture. Say, for example, in-memory databases come in. How are you going to tune the query optimizer to have a new cost model? So you don't want to rewrite the query optimizer again and again and again. So in the networking field, what happened is true innovation started happening when the networking stack was divided into multiple layers. So we wanted to do the same thing for databases. We wanted query optimization as a clean API that anyone can just plug into their database system. As long as they can satisfy the API, they can use that layer. So we wanted to abstract out that layer for databases.
So in that sense, then, what are some of the top 3 layers or components of an optimizer or Orca? So if you look at it, are there, like, here's this part, here's that part? What are the parts?
Yeah, well, what is the architecture? Yeah.
So, one second. So let me share with you my screen so that we can point to a figure. So this is I don't know whether you guys can see the architectural view of Orca. So what we wanted to have in Orca is, first thing, let me start bottom up. So databases are notorious of not managing memory well. So we wanted to make sure query optimization, when you are searching billions of plan alternatives, you are memory sensitive. So we wanted to have a clean API and as well as accounting for all the memory we use. So we wanted to have a clean API for the memory. So that is GPOS. So that is the first API we wanted to build on. We wanted to build on strong software engineering principles. The second thing we built is we want operators, different operators, logical and physical operators, to be unique. And then the logical and the transforms that apply on it to be unique. So in traditional optimizers like Postgres and others, you go through a bunch of rules to get to your final goal. Instead, in Orca, what we say is, hey, I have a join operator. I can do different transformations. I can convert it into a nested loop join. I can convert it into a hash join or a merge join. That's all that the join operator tells me. How to actually do the transform from one logical to another physical is a unique modular transformation. So you have a library of operators, you have a library of transformation, and then you have an engine that fires these operators at a specific order or an order specified by the data engineer, DBA, or by Orca itself. So you want the operators, the transformation, the cost model, the statistics, all to be independently be able to fire on any given operation. So this is very unique in Orca, which is not there in other query optimizers.
Venki, on this architecture diagram, it's good. It's like a block diagram, but how do we understand the flow? Like, so the query comes in, what's the stages or the flow of it?
All right. Let me pull up this.
Yeah.
So here's the architecture of. So Orca is not baked into any system. So a SQL comes in, the parser converts it into whatever database system, whether it's Hadoop, Hawk, for instance, or if it's GPDB. It takes the query object and converts it into DXL, which is a tree representation that Orca understands, the language that Orca understands. So it then converts it into Orca and gives it to Orca, right? Inside Orca, it takes this logical expression, and the engine starts saying, hey, you are a join. I need to join you. But if I have a hash join, I may need to do an implicit cast or something. So how do I go about finding out what is the cast function? So I ask for metadata from the catalog. And the catalog then says, hey, I have this cast function that can convert this data type to this data type. Or I have this table statistics that you may want to know to do cardinality estimation. So again, the metadata is provided by Orca as DXL. So Orca keeps asking the host system for different things. Hey, do you have an index? Or do you have statistics for this? Do you have constraints?
It doesn't get all of the information up front.
It doesn't get up because, so you may have hundreds of tables. For instance, you may be querying on a partition table with 10,000 partitions with 100 columns in each partition table. You don't want to get all the information. You want to do it on a need-to-need basis. So, but as you can see, it may to prevent this loop around time. So what we do is we cache the metadata. So we don't have to keep going back to the host system for some things that we've already had information about. So we cache them either within a query, or if you want between queries, you can cache the metadata that you are getting from the host system.
So is there any other architecture similar to GPORCA? I mean, I know that this differentiates against, Planner and Postgres SQL and some others that are more traditional, but anything similar to this at all?
So Orca is based out of Cascade/Volcano-based query optimization. Cascade and Volcano usually are used interchangeably. So this is based out of research done 20 years ago or 15 to 20 years ago from Oregon State. And there are many query optimized, one or two actually, enterprise production ready query optimizers which are similar. One of them being SQL Server. So SQL Server's query optimizer is very similar because they are also based out of Cascade.
So and back on this one though, I'm still not seeing the flow. So I see the high level flow is that you parse it, then you get the metadata. But what about the steps? Like, what is Orca's game plan once it has the metadata?
So once the game plan is done, first thing what we do is it doesn't show in this figure. The first thing is do some slight pre-processing. So for instance, we say, for example, push all the selectivities to the table so that we reduce the scan of the tuples. We say, hey, if you have superfluous predicates, say, for example, if you have predicates that are repetitive, then just remove those things. If you have predicates that are contradicting each other, then you can no need to avoid computation altogether. So we do some pre-processing.
Are you still working with a logical plan, or you're with?
We always work. This pre-processing is always done in the logical level. So once the pre-processing is done, what we do is that we shred everything, the whole logical plan, and putting into a memo. So this is the black box. This box with small black rectangles is the memo. So a memo means is one memo level. It has one operation. So say, for example, if you have a select on top of a scan, the scan will be on the bottom rectangle, and the top rectangle would have the select condition. So for each of these memo groups, we then go and say, hey, engine, figure out what transforms can I run on it. So the engine will go and say, hey, who's in this memo group? Oh, you're a select. What it says, it asks the select operator saying, hey, select operator, what are the transformations on you that I can apply? So each operator registers, hey, you can apply an index scan here because it's a select condition. You can apply select to an index scan, or it will say no, or you can, if you don't have an index scan, you can also apply a simple computing the predicate as a result node.
So, Becky, are you talking about now from the memo trying to convert from logical to physical operators?
Correct. So what I'm saying is so say, for example, I don't know whether you can see my mouse.
Yes,
the top big rectangle is one memo group. So with this example for us, we have a select here. And the second one is just a scan on the table foo. Mm-hmm. So for each logical operator, we go and find out the list of transforms. The engine will go and find out the list of transforms. Who gives us the list of transforms? We get it from the operator. The operator can have both logical to logical or logical to physical transformations.
Vicky, I have some slides to help you. If you let me share my screen.
Sure.
Yeah. So far I cannot because you shared.
Stop sharing. Hold on. Sorry.
Here we go. You guys can see it?
Yeah.
So this is the transformation explanation. Go ahead, Wenki.
Shin, is this in the pre-processing where you're doing logical to logical?
So we have done the pre-processing already. So this is the steps. So first we do pre-processing, and then we do exploration. And after exploration, we do statistic derivation.
Okay.
We do implementation.
Okay.
And then lastly, we do MPP optimization, which is enforcing distribution spec and costing and actually getting what is the optimal plan. So if you go, thanks Shin for sharing the slide.
Sure.
So if you have this, so if you, this query has to do with the join between T1 and T2. So you take the input logical tree, which is a join between T1 and T2, and shred it into 3 groups. So group 0 has the join operation, group 1 has T1, and group 2 has T2. So now for each group, we go and figure out, hey, what are the transforms I can apply for it? So for inner join, you can either from logical to logical, you can swap the join order. So it can be 1-2 or 2-1.
How do you know if, so you have some representation and you're going to be looking at all these transformations. How do you know if it makes sense to do a transformation or not? Like that there'll be a gain for doing that?
Okay, so you have, so for each group, you are at one point, which is the 4th phase, and the phases are not it's not necessarily sequential. That means if we do, for some plans, we do a cost estimation early on so that we reduce the search space. So for logic, at the logical level, you don't do costing. You only do costing when you have physical, because you may have to introduce motions if in a distributed system. So, and a logical join does not have a cost. A nested loop join has a cost, or a hash join has a cost. So we don't do cost estimation for logical operations. So during the exploration phase, basically we come up with all alternatives that we can get. So we just expand the space. And then during costing, we shrink the space again.
So during exploration, you're listing out all the potential plans?
Correct.
Logically plans.
Yeah, all the logical plans, correct.
Logically equivalent plans.
And could that be like too many? Could it be like a quadrillion?
So for TPCH query 1, for Orca generates 1 billion plan alternatives.
But if it's, let's say the query was like super complicated, could just in the logical phase, you blow out the system by having too many alternatives?
So we could have that. So we have checks to manage that. So for instance, one of the things, see, most operations don't expand the plan too much except for join order. Okay. So join order, it's a permutation combination of what's the order in which you join. So what we have done is that if you have more than 7 or 8 joins, we should not be exploring all alternatives, because that will really, really take a long time. And the query, the data, there may not be enough data to warrant such an expensive search. So we circumvent those scenarios. So if you have more than 10, we will be very greedy in picking the join order and not explode this search space. So there are few places where we can explode that we know that we can explode, so we have circumvented that.
Okay.
So let me ask you something a little different here. So the whole design and architecture is very modular. What is modularity important within the design of?
So let us go back to this example that Shin, can you go back to that?
Okay.
So let me give you an example with regards to if you want to come up with a new join operation, right? Say for example, many of the folks in the market are doing collapsing of operations, collapsing on code generation, vectorization, all of those things. So you want the optimizer to decide whether you should collapse multiple join operators into one mega join operator, or say, hey, should I do code generation for this expression? So if you want to add, these are new technologies that people are innovating right now. So if you want to put that in here as a cost model, it's very trivial because a join operator will uniquely tell me what the cost is. It should not affect how you search or how you cost the rest of the plan, how you introduce motion, how do you trigger statistics. So any innovation that you are doing should be touching on local parts. That means either you're adding a new operator or adding a new index scan or adding a new execution technique, and so you want to tune the cost. So you only touch those code that will affect the optimizer to pick what you want to pick. So that's why modularity is very important. Otherwise, what happens, you have to touch the whole bunch of components to get the desired effect. And by doing that, what will happen is when we are doing iteratively programming, an engineer comes in and puts in their changes, they may not know if you have states that are maintained across 10, 20, 30 files, there is a high probability that you're going to screw it up.
You're saying that when you modify code in Orca to improve the optimizer, you won't impact the entire optimizer by making a
Correct. So if you want to add a new operator, go ahead, add a new operator. These are the things that, you need to tell me what are the transforms that can apply for it. The transform is independent of the operator. The operator is independent of the transform. But they say, hey, I need to operate on that one. That guy is sitting there, and the operator says, oh, this is the operator that I want. Or this cardinality estimation is in this module for this. And all of these are separate. So it's basically like you're adding a new spice in the kitchen. You don't have to rearrange the kitchen for adding a new spice.
Let me also ask you about, and basically, what are the best use cases and queries that perform the best with GPORCA?
So,
or in comparison to, let's say, to the Postgres planner.
Yeah, comparison to Postgres planner. I mean, it's a different kind of.
Humans are very complex. So we tend to run complex SQLs with a lot of nesting and iterative, because we think in an iterative fashion. So because humans write software, so any BI tool that are written by humans also have a lot of nesting and a lot of organization by with clause, by nesting, by partition table. These are the cool things that we write. But this also adds a complexity to the query optimizer. Say, for example, if you have 4 levels of nesting, correlation in a query, and you have a monolithic query optimizer, it is very hard to always decorrelate it into a query plan that can be done by a hash join. So Orca really shines in that. The reason why it shines in that is that it doesn't see the big picture when it's doing small transformation. So it just says, hey, I'm going to transform this one level this way. So you push the envelope forward. And then the other iteration again does it. So, but you still have all the options on the table. When you go for costing, you know how much the decorrelated version versus the correlated version can cost. So you have not committed yourself in having a decorrelated plan. You're committing it. The optimizer is doing its job of actually observing all the different plan alternatives. Or another one which we do very good job is partition enforcement. So what we do is that we do good static and dynamic partition elimination. So currently in Planner, what we do for doing dynamic partition elimination, we have to execute the subquery twice, which is not as optimal if the data set underneath is too large. Instead, Orca does dynamic partition elimination without doing multiple scans. The plan at least does that. So another one is common table expression. With many BI tools, we keep writing with classes and use those with classes multiple times. So in Orca, even in the latest Postgres planner, say for example, you use the same with class multiple times and you use the same sort order, Postgres Planner does not take into account that we need it in sort order, and we can do it once and share that sorting. So these are some small examples of where Orca really shines.
Hey, let me ask you, actually, this is a question from the audience. Basically, it's asking about, his name is Jeff, he's asking about the comparison, if there's a comparison between GPORCA and whatever Amazon Redshift used for query optimization.
So,
yeah, go ahead.
So because Amazon Redshift is a closed source product, so I can only guess at best of what they're doing. But given the fact that they are based out of a Postgres 8.0, I'm assuming that their plans are similar to the planner, the Postgres planner that was forked 7-8 years ago. I am sure that they have made enhancements, but because it's a closed source, I can't comment in an intelligent way. But yes, they are a Postgres-based planner, and they have the same shortcomings as GPDB planner or any Postgres-based planner has.
Anyone else have anything to add to that? I guess no.
There's two more questions here from the chat. From Marshall, he says, do you do any branch and bound algorithms to pare down the search space in join orders?
Yes, we do. Actually, if you actually see the open source GPDB, there is a knob. It says optimizer underscore prunes space plan space or something. It does do branch and bound. So that for a given optimization context, it finds the best plan. If the child is more, then we totally eliminate the whole subtree of alternatives. We do branch and bound.
And Balaji is asking, can we force a like use specific join operation like NL over hash joins like a hint?
So we have there is a way, there is a UDF by which we can force Orca to not look at transformation. So I am actually writing a blog article of all the transformations that Orca has and how you can disable or enable them for your customer or for your use case. So yes, you can disable this transform. It's called select space disable underscore transform and the transformation name. But we will be coming out of the blog article soon, and you can do that.
And there was one more catch-up question here, which was from Nadar, which says, he wanted to understand if you have two optimizers in the same database, like Greenplum, you have the Postgres planner and the Greenplum GPORCA. How does it decide which to use or fall back?
So there is there is a knob right now in GPDB 5 and 4.3. Any GPDB version after 4.3.5 with set optimizer equal to on or off. So when you say set optimizer equal to on, it picks Orca. So any query that comes in or which Orca can support, it'll go through Orca. If it doesn't support, it will fall back to the planner. So that is one way. So there is some interest in having a more BI, some analytical tool that can decide for you which are the awesome queries that you want to run with Orca, but that is still in the proposal state.
Hey, I have a question actually more related to the open source nature of the software. So if you have a pull request, specifically from a user in the community, how long it takes to resolve that pull request? I mean, typically.
So the way we in the GPORCA world, the developers at least, the way we operate is that anytime a pull request comes in, we create a chore in our backlog and we put it on the top of the backlog. So within a week or 2 weeks, if it is not architectural changes, if it's just adding a new operation, and it is only inside Orca and not the translators in GPDB, it should not take more than 1 to 2 weeks. But if it is a big proposal to add, say, for example, a new cost model, I'm sure we're going to have some interesting conversations about it, and it's not going to be 2 weeks.
I have another question for Marshall. What does ORCA not support at the moment?
So Orca currently, we don't support catalog queries. We don't, not that we cannot support it, but we automatically fall back to the planner. So another one we don't support is we don't support cubes. We don't support external parameters. We don't support surf functions which come in the from class. So why we don't support it is that we actually want to hit it. We want to drive the big use cases that which are important to the client customers and the open source public. And these are some things we thought that we can delay it for our next iterations.
So what do you like most about ORCA, or GPORCA, I meant to say?
Shin, do you want to answer that question?
Yeah, in last year, my favorite part of the GPORCA is the enforcement framework. I know we haven't touched it yet today in the discussion, but that's like adding a magic sauce, like adding the secret sauce to make this dish really, really good. If you're looking at those stages before, like pre-processing, exploration, stat derivation, implementations, almost all the query optimizers are doing it. But before the MPP optimization, which is the property enforcement framework, the query is only for single node. It's not optimized for a cluster at all. It's not optimized for the MPP process. It doesn't know about the motion. It doesn't know about where to find the data, how to distribute, how to gather. It has no information for that. And that secret is actually happening at the very last stage where you do the enforcing. And it all based on properties, like saying how the data is distributed, what kind of operator can do to change the distribution. Even the data is sorted or not, the way they distribute it is there. And also it's very extensible. The framework, thinking about so far, we don't distinguish between the data is in a cheap connection or costly connection or a far, far away source or local source. I mean, a near network transformation is better or worse, but those can all be classified as new properties and added and extended to the GPORCA. Then the framework can handle it. It's magic. So that's my favorite part of the GPORCA when I'm playing with it.
So if when we, there was one thing of having replicated tables, which has been always in frequent discussion. To add that support in GPORCA is going to be straightforward.
Yeah.
Because it is just another property.
What are you guys working on? What's the future of GPORCA at this point? Roadmap, can you comment on that at all?
So one of the things we are looking at closely is customers and open source developers, they know how their workload is, and they want to provide specific user hints. User hints saying if that, hey, this kind of queries, I want you to pick this. I know the statistics of this, and therefore I know that we need to go this route. So we want to support intelligent hints in ORCA. So we are still in the proposal early stages of how it will land. So that is one, we have a couple of charters to look into that. Another one we want to look at is to do multi-stage query optimization, where we want to have different ways in which a customer of ORCA can align the query optimization steps, so that after the first batch of transformation, if they have a plan, they can immediately ship it. They don't have to wait for all plans. So that is one customization. Another one is that given that we have different IaaSes, different places where GPDB and Hawk are being installed and run, we need to tune our cost model for those different infrastructures, different machines, different networks. So we want to have a tool that will automatically tune your database system and give ORCA the costing that it needs so that it will generate a plan that is awesome for you. So those are a couple of big ticket items that we have in 2017 and 18.
There's some questions here from Alvaro from Madrid. Says, How will GPORCA work for queries on federated data sources? Imagine external data sources like Postgres foreign data wrapper. How are the statistics accessed in this case, and how well would it work under that scenario?
So currently we go through the statistics of the catalog. So Orca doesn't care where the statistics is coming from. Right now, it only accesses either from a file or from a host data catalog. But we can do extensions that can get it from, say, other S3 or other kinds of storages or other federated data systems. We can do that via DXL, but we haven't explored that.
So in Postgres, actually, foreign data wrapper supports analyze on foreign tables. So in terms of how much change Orca has to do, virtually none. But as a whole, Greenplum database has to add that support so that we can actually get statistics from foreign tables.
So the Postgres upgrade in Greenplum?
Yeah.
And which version has that?
The first version that has FDW.
9.1.
So in Postgres, you can say create server, and then on top of a server, you can say create foreign table, and then you can actually run analyze on your foreign table. So similar things has to happen in Greenplum for us to have a unified way of supplying statistics. So that like, in terms of like how much change Orca has to do, virtually none. But we have to be able to get the statistics first. Otherwise, we would just assume something like 10,000 tuples or some other default stat, basically. This is how it currently looks like.
There's another question here from actually both Marshall and Balaji. There's a kind of discussion going on the chat about hints that work for a particular version. I mean, especially they're talking about Oracle. Hints that work for a particular version in Oracle, and then when you move to a newer release, it could be harmful to whatever you're doing. How do you manage that? With GPORCA in particular.
So one of the reasons why we are very hesitant to put knobs is that when you commit to a knob, you have to stick with it. Otherwise, you create a lot of confusion. So any knob that we have introduced, we have not taken away. So that's why we are very, very diligent before we add a knob. So we don't change knobs between releases.
Got it.
And there was one more from Avero here, which was, is there a plan to add query compilation capabilities to GPORCA? Is it possible?
Can you elaborate?
Maybe Caesar, can you unmute Alvaro?
Sure.
Introduce himself.
I think he's, yeah. Oh, sorry. Here. Go ahead, Alvaro.
Thank you. Thank you for that. Yeah. So basically, there's been some approaches lately to support query compilation. Like Spark has this project Tungsten. There's all the databases who use LLVM to generate native code for query execution. So I understand GPORCA does not physically execute the query, but it might be interesting to know whether there is some capabilities that might be related to this, so that query can be compiled to native code or bytecode on JVM and then execute those on the host system later on.
So one of the things I agree with you. The optimizer has some meta information which it can tag the plans of saying, hey, these are the points you want to do code generation, for instance, or doing LLVM, or something that is an operation that is better to do LLVM. So we haven't explored that, but to add that stage would be straightforward. It will be just it's a post-processing that says, hey, these are some of the code generation or LLVM techniques.
So Venki, would that solve the issue where, so let's say we introduced a code gen feature and we just had it as a global setting on or off. Then the user has to know what to do with that, right? So based on what you and Navarro are talking about, could you get away with that? And there is no setting. It's just that the optimizer will introduce code gen when it thinks there's a benefit.
Correct. When it thinks it's a benefit based on the statistics and saying, hey, for this, generating code is actually going to take more time than actually running the query. So don't do it. It can overrule the consumer's overall knob.
And what about like specific operators or super operators that could do code gen?
So one of the things that the query execution team was looking at was to do an array physical join operation. When you have no motions and you have a stack of join operators, to collapse them into a single n-array join operator that can dynamically change the join order based on actual data that's coming out, and to do batch process, both vectorization and code generation, all at one shot. It can do that, but it was just a couple of proposals that we were talking about in our meetings, but we haven't implemented that, but it's definitely doable. Basically what you will have to do is to do a transform in Orca that takes a tree structure and collapses into a physical mega join operator. And then little bit of knobs in the translations, and we go out from Orca. But I think that's quite doable, probably a couple of weeks of work.
And what would be the impact of that?
So there has been shown many experiments at least in academia, and I think to some sense, some of the Hackathon and a couple of other competitors also do that, where when you have mega operators and do batch processing, it's very, very fast. So it is something that one could explore.
Like potentially more than twice as fast?
Sometimes 10x to 20x faster.
That's a lot faster.
It is something that is doable.
Do we have any other final questions in the audience, please? Yeah, I think we have another one.
I think this is kind of a pivotal-oriented question. Maybe we should skip that one.
Yeah.
Sorry, Balji.
So, where can people download GPORCA? You guys comment on that?
So GPORCA, if you go to GitHub, Greenplum, GPORCA, there's if you even Google GitHub GPORCA, you will hit, I think the first two hits, I think, is the GPORCA GitHub page.
Or get the latest version of either Greenplum or Apache Hawk incubating. Yeah.
And you will have to install Xerxes, and then
if you compile it yourself, you have to install it.
So correct. And one thing cool about GPORCA is for a software engineer or someone who wants to play around with the query optimizer, they don't need actually a database. So if you look at all of our tests, we have extensive tests, about 93% code coverage. All of the tests are done from a file. That means the file becomes the database, which has all the metadata, and you can do a proof of concept without even touching the database.
And how accessible, let's say you have an open source, a person in the community who's, let's say, a student, and they want to learn about query optimization. How accessible is the code base of GPORCA to start hacking on?
Come to pair with us.
Yeah, we pair remotely. Just ping us and we'll help you out.
But even besides that, how approachable is the code itself?
The code is divided into operators, transforms, all different folders. So we do have a paper in Sigma, a couple of them, and one in BLDB. It's a good starting point. It is an optimizer, so it needs some dedication of getting through the code and how it is structured. But once you get the flow, it's straightforward.
Do you need to understand relational algebra?
That's true.
To a certain degree, you don't have to be taking Jennifer Widom or another Stanford professor's course to do this. But
what was the prerequisites? Let's say I'm a computer science graduate from bachelor's degree. What are the prerequisites to be able to know enough to start hacking on Orca? What kind of books should they know or read, or what's the minimum knowledge?
Hey, Jesse, do you want to take this?
Oh yeah, because like I have the lowest kind of academic degrees on the team, and so I guess you just have to graduate from a CS program, or not necessarily.
Actually, not necessarily.
I always recommend that people just come in and pair with us, because I am a big disbeliever of documentation, and I always believe in just holding people's hands. And my hands have been held like a billion times. So, but in terms of like prerequisites, like if you have an introduction to database systems class in college, and that will be as much as that's needed.
So you don't need any math. You don't need linear algebra. You don't need
None.
Wait,
If you're
that's
doing
all the prerequisites
statistics,
of the
maybe.
database class. So yes, but not really. Like if you're not stupid, you're good enough.
Okay.
It's a low bar.
Yeah, it's pretty low bar. So even I can work on it. So like,
Yeah, like one of the reasons why we wanted to decouple the different parts of query optimization is to make it simple enough that I know Ivan was trying while he was flying across the states.
So
Trying
yeah,
to
so I took it as an initiative to add I think it was gist indexes to Orca, and I got as far as seeing that I could actually figure it out and do it, but then I gave up because I had other things to do. But I saw that I could have done it if I wanted to, and to be honest, like what I saw is the biggest gap for me was relational algebra, and just having a basic of, you know, what is these different operators, what is the logical operators, and what do they mean, and
I can cover all of that for you in 2 hours.
or if you could, we should put out a link to what's the best way, is there a resource that someone can read.
Sure. We definitely more blogs would definitely.
I also want to comment on like the potential of Orca in like different areas of computer science. So it's not just if you want to do a research on related like high performance computing or any other networking issues or systems research, you can also utilize Orca in that area also.
How?
Because it has all the semantics of like the distributed systems. So you can, even though you don't know anything about databases, the data distribution is another subject. So you can tune the cost model and come up with different results, and actually it will give you a good base point in different research areas as well. So I also want to point out that because my background is not in databases, and I actually see a lot of potential in Orca for utilizations of the different research areas.
So he's coming from an MPI.
Well, high performance computing in general. So yeah, I just wanted to comment on that as well.
Okay, so I'm not sure if there's any other questions, but
Sounds good. Let's wrap it up.
I'm gonna wrap it up. Okay, and that was our GP chat on GPORCA. Thank you for watching it. Please download the Greenplum sandbox at greenplum.org. I'll see you next time.